In this video, we're going to be looking at finding values in graphs of functions. So in this question, we have the function of x squared plus 2x minus 3 in the domain from minus 4 to 2. You can see the graph of this quadratic here below. So we have various questions here that come with this question. First one there, solve f of x equal to 0. So if you ever have to find where f of x is equal to 0, that's simply where your graph crosses the x-axis, otherwise known as the roots of the equation. So we can clearly see that this graph here crosses at minus 3 and 1. So they are the roots of the equation. So x equals minus 3 and x equals 1. Now the next bit, so solve f of x equal to 4. So if you ever have your f of x equal to a value, you go to that value and you draw a straight line from your y-axis. When you hit the line, when you hit the graph, then go straight down. So 4 is here, so let's draw a straight line. Make sure you go to both sides. Now when you're doing this, you need to make sure you're using a ruler. When I'm hitting the graph, then I'm going to go straight down. Okay, so again, when you're doing this, you need to make sure you're using a ruler. So for this, I'm going to hit 1.8 and minus 3.8. So they are my answers for this one. So 1.8 and minus 3.8. Next one, so find the value of f of minus 2. So if you have f of then a value in brackets, you can see there that the x has been replaced with minus 2. So I could just actually sub minus 2 into my function. But if it tells us to draw the graph, if it tells us to use a graph, we need to make sure that we're using the graph. So I'm going to go to minus 2 on the x, go straight down. Now as soon as I hit the graph, let's go across. So that would be minus 3. Again, make sure that you are using a ruler when you do this. Then find the minimum value of f of x. So that's the lowest point. So we can see that the lowest point is down here, and that is minus 4. The last part then, so find the equation of the axis of symmetry. So this is just the line that will split this graph in two. So I could see if I drew a straight line down here, you can see the one in yellow, that would split the graph completely in two. And that is the line of x equals minus 1. Okay, so some more questions for this graph. So the range of values of x, which f of x is negative. Okay, this is when the graph is below the x-axis. So I can see that this graph is below the x-axis in this region here. So as soon as the graph gets to minus 3, then going all the way to 1, it's going to be negative. So the range of values for which f of x is negative are between minus 3 and 1. I will write this as an inequality, like that. So between these values, our graph is negative. Next bit then, so the range of values of x for which f of x is positive. So this is when it's above the x-axis, so here and here. Because any value you pick from 1 on is going to be positive. Likewise, any value you pick from minus 3 going down, getting smaller, is going to be positive. Because your quadratic is going to keep going on and on and on. Okay, so all those values will be positive. So this is when x is less than or equal to minus 3, and x is greater than or equal to 1. The next bit then, so the range of values of x for which f of x is decreasing. So this is when it has a negative slope. So remember, a negative slope will go in this direction. That is a negative slope. So I can see this has a negative slope from my first point here, -4, all the way down to the tip here of -1. So between -4 and -1. Okay, and I'm actually going to change that to just less than -1, because at -1 it's going to have no slope. So between -4 and -1. Next one then, so the range of values of x for which f of x is increasing. So again, going from the bottom here up to the top, because a positive slope will go in this direction. So we're going from -4 to 2. X is greater than -4, less than or equal to 2. And that's it. Okay, we'll look at another example. So here we have a negative quadratic. So f of x equals -x squared minus 6x. So solve f of x equal to 0. So this, as always, is where it crosses the x-axis. So we can see that this is -6 and 0. Solve for f of x equal to 8. Okay, so we'll draw from the y-axis. As soon as I'm hitting the graph, we're going down. Again, you would always use a ruler for this. So that gets us -2 and -4. Okay, the value of f minus 1. So I'm going to -1 on the x-axis. Going up. That gets us 5. Again, make sure you're using a ruler. The maximum value then, so that's the highest point, which is here. So the maximum value of f of x equals 9. Then the equation of the axis of symmetry. So the line that splits in two. Okay, this line here splits completely in two, and that is x equals -3. Okay, so next one, so the range of values of x, which f of x is negative, so when the graph is below the x-axis. So in this one here, we have no domain. Okay, so the graph is just going to keep going on and on and on. So you can see it's going to keep going negative here and negative here. So it's going to be negative here. This is when it's below the x-axis. So when x is less than -6 and when x is greater than 0, that is when your line or your graph is going to be below the x-axis. Then the range of values for which f of x is positive, so above the x-axis. So all here. So between -6 and 0. Like so. The range of values of x for which f of x is increasing. So again, this is a positive slope going this way. And now we have no specific domain. So it's going to be increasing any value on this side. Okay, because any value over here, it's going to be a positive slope going up like that. So the range of values of x, which f of x is increasing, are when x is less than -3. Because when x is less than -3, that graph is always going to be increasing. Now the range of values of x, which f of x is decreasing, this is a negative slope going down like this way. So again, it's from the top here. As soon as it gets past -3, it's going to be decreasing. So when x is greater than -3, and that's it. Any questions, please leave in the comments.